Okay, well, let's get started. Welcome back, everybody. This is the 11th lecture. Semester is moving awfully fast. And today, Juliano is going to cover widgets in IPy notebooks, Jupyter notebooks, and then we're going to move on to talk about some more antimony coding, and then eventually getting to the feed-forward network that we keep threatening to talk about and never seem to get to. And if you want, you can read about feed-forward networks in chapter 14 of the textbook, which is all about that and discusses what we're going to do in some detail. And Juliano has generously agreed to lead the lecture off by talking about widgets. So the outline will be Juliano going Jupyter Notebook widgets, and then depending on when he finishes, we will start on a little bit on antimony function definitions, and then ODE specification in antimony, and then we will jump into feed-forward networks. So I will turn it over to, actually, before I do that, let me just say, let's just do a review. So I just want to come back to a couple of key concepts from 2 weeks ago. One of which was the idea of how to analyze motifs, and this idea that you start out by plotting time series. So you have some idea of how the system behaves. You identify fixed points, and we talked a little bit about using running time backwards to find unstable fixed points. We didn't really go into that in a lot of detail, but something we can play with. And then we introduced the idea of phase portraits for representative parameter sets, determining transitions between fixed points under perturbations, and which is something that's very important biologically. And it's not really a classic element of dynamical systems analysis, although it's there in the background. And then classic bifurcation analysis, looking for parameter values at which the number and stability of fixed points change as we change parameters. And we did this for a couple of examples. 2 weeks ago, we dug through the homework in some detail, looking at B, which was autocatalytic molecule, C, which was effectively a relaxation oscillator, and then E, which was a toggle. And we found here this clear 2 fixed point system for B. For C, something more complex where you could go to a fixed point, a high value fixed point, a low value fixed point, an intermediate value fixed point, or oscillations. So you could have coexistence of oscillations and fixed points. The idea of doing perturbations, bifurcation scans, and then these phase portraits and these red lines, which are null lines, which we haven't really discussed in detail yet, which you could come back to. And using these as a way to try to understand the structure and analysis of dynamical systems. And then I'm going to turn it over to Juliano to talk about widgets.
Yeah, so today I'm going to show you all how to use widgets. That would be important for your projects when you actually publish them and make them available to the public, so that you can have the user do something instead of just reading and looking at graphs, and perhaps learn something more with the interaction than if it were just static. My plan is for the section of the lecture to be a bit more hands-on, and so I'm gonna do it all on Jupyter notebooks. And if I'm a bit low, do tell. I can try to boost my microphone or anything.
I think you sound all right.
Okay. Okay, so let's get this ball rolling. Where is my Jupyter? Here. Cool. So this is Tellurium on NanoHub as usual. Might as well use the thing that you have to use rather than some local installation. And there are a few reasons for that. that I will get into soon. So as usual, importing Tellurium. The other two things that we are gonna import are the IPy widgets, which is interactive Python widgets to actually have the sliders and whatever else. And then interactive Python display to actually show the widgets in the notebook. And later on, I may use some matplotlib and numpy as well. But for now, you only need that. And yes, do raise your hand if you need more time or anything to get the Tellurium running and whatever else. But while you do that, I can show you why I'm doing this in NanoHub's Tellurium and not my local Python installation. And I can do that if I print the version of the widgets package, which in Tellurium, which in NanoHub is 712. But if I search for IPy widgets online, I can see that the current version is 8.02. And apparently there actually are quite a few differences between 7 and 8 to the point that they put out a page just on hints and instructions on how to go from IPy widget 7 to IPy widget 8. Thankfully, they also kept the old documentation page for the 7th version. So we are still good, at least for now. But yeah, that's the reason why to do it all in NanoHub's Tellurium.
Or if people download the version 7 on their machines too, right?
Yes, 712 on your machine should also do the same thing. But you know, I guess it's more safe to do it all on the platform that will host your thing afterwards. But yes, if you download the 712 version, you should be good. And before we actually get started as well, one thing that I can do is something that James loves to do, which is to do a dir on the package. And that way we can already see what things we'll have available. And yep, there are several different options. We can have a date time menu. We can have a drop down. We can have a slider that is a range or floats. I think that's the same thing. Yeah, a slider for integers. Apparently you can use this to save passwords and things, and so on. So how do we actually do anything with this? Well, we can start by making a simple integer slider. It's somewhere there. And I'll make that in this cell here. So I'm gonna have a int slider. It's gonna be equal to, well, it's gonna be a widget. So it's part of the widgets package. And I want a integer slider. So that's int slider, and that is somewhere in here, or it should be int range slider. Here, int slider. So that's one of the options. And then you can set several directives for it. You can give a minimum number for it to display. I'm going to do -9. Of course, you can do a maximum number for the slider. Otherwise, defaults will be used. And I'm going to guess that it's going to be 0 and 1 for defaults. And I'm going to make one from -9 to 10. Then I can control the step for the slide ticks. Then, of course, since it's an integer slider, my steps have to be integers. And I've actually tried to do this with less than 1 greater than 0 number, and the slider simply does not work. It doesn't throw an error, it just doesn't do anything, which is funny. So I'm gonna set a step of 1, which is probably the default as well. Then well, let me actually just run this. We don't see anything. And that's where the second package that we've loaded up comes in, the IPython display. So if I do a display on the int slider, now it's going to show. And now we have our first slider, and it goes from 10 to -9 as promised. But yeah, that's all we have. But you'll probably have something like this slider controls this rate in this model. So you can add a description to the slider when you create it. And that can be any text. So my first slider. If I rerun it, we see that description shows up here on the left. But I do need to be mindful of the length of the text because it will eventually cut itself off.
Sorry, I'm not doing because I cannot find it. What is the tool that you're using on NanoHub? Is it NanoHub? No,
It's Tellurium.
Tellurium? Okay.
Yep. I'm using Tellurium.
But have you tried to put a new line to see if something changed like that? If the description go on top of the slider? Like a /n, \n.
See what shows up. No, doesn't seem to do anything. But it's funny because if I have my first slider, it goes until the end of slider. But then I put in a bunch of chunk afterwards and it cuts on slit. I'm guessing it needs to find space to put the 3 dots.
There are options for hand formatting those things, but they get pretty ugly. You either use the default format for the text display, or you have to do everything by hand.
Yep. So I would suggest a very short description if possible, and then you can have the cell above be a markdown cell, and you can better explain what the slider options are in Markdown instead of having to rely on the slider text box. If that makes sense. Yeah. And there's still one final thing that we can do with here, which is if I rerun this, I'm gonna set it to a number. It's gonna start at 0, but I can actually make it start at some other number if I pass it value equals 4. Now it starts at 4. And that's the most basic thing to do with sliders, but we can do more. Well, we now have a slider. Obviously we can change whatever value it's displayed there, but how do we actually use it? Well, we can get the value of the slider by doing the name of the slider. So in my case, it's int underscore slider period value. Now that repeats whatever is in here, but you can see that I've moved my slider and this value hasn't changed. But once I rerun the cell, then it updates. And of course, I could do anything I want with this value. Could save it to a variable and then print the, well, not the square root because we have negative numbers, but I can get the third root and that should be fine. Well, it's fine regardless because Python has a notion of complex numbers. Anyway, yeah. So I'm changing the slider, then I have to rerun the cell, which is not that helpful. I mean, you want something to actually be interactive instead of having to change something and wait for the user to do something else to finally have something occur. But one thing that we can do is instead of setting as just a slider like we did here, we can use the interact function from the widgets package. So what I will do is first I'm gonna import matplotlib and NumPy. Because now I can do some plots. Yeah, there we go. So I'm gonna define a function. I'm gonna call it circle. You can imagine what I'm gonna draw. And well, circle of radius I. Have to define a theta. Gonna be from 0 to 2 pi. 150 points should be fine. Then our x is gonna be now if I call circle 6. Wait, what?
Do you have NumPy imported?
I do.
Oh, yeah, you do.
Why? I mean, it's a circle. I'm fine.
I think you might have a minus instead of an equal sign in line 3.
Line 3.
Could just be my screen though.
That's an equals.
Okay. Oh yeah.
What did I do wrong? I mean, I did take the flu and COVID shots yesterday, but I didn't think I was this under.
I think it has to do with the third value in your numpy.arange.
Oh, yeah.
Yeah.
Yes. Yeah, I always get the range and the other one mixed up. So if it's step size, we can do a step size of 100th of yeah, there we go. Thank you. Okay, so we have a slider that doesn't do anything by itself. We need to keep rerunning stuff. And we have a function that draws a circle of a certain radius. Of course, the aspect ratio is all wrong and whatever, but it is a circle. And in case you want to fix the aspect ratio, that's pretty simple. There we go. So how do we make this slider interact with this function? Pretty simple. We use the widgets dot interact. And the function interact from widgets takes as first argument a function. So in our case, it's going to be the circle function. And as second, well, as a named argument for Right. And a second argument, it needs to be whatever argument name the function has. So the circle function has a argument of radius. So we need to do radius equals something here. And it's going to be equal to the int slider. Hopefully this works. Yes. So now we have the same slider as before, my first slider. And if I scroll this, we get a circle of increasing radius. And if I go negative, we also get a circle of increasing radius because that's how circles work. One thing that I've said is I said the same slider. And usually in Python, when you use the equal sign to something else, you're creating a copy of it. Sometimes that's not true. When you do that with functions without calling the function, or in this case with slider, what happens is that you're creating a pointer to the object slider that already exists. So set this thing to -9 here with the circle. And now I'm going to scroll up. It's -9 here. What happens? Yes. What happens if I throw this all the way to 10? What will the other slider show? -9 as we set it to be. No, 10. It's literally the same slider. It's not a copy of the int slider. It is int slider, the object. So any change we make here shows up here and vice versa. So that's something to keep in mind afterwards. You can't create an object. Say you have 10 rates on your model, and all of them are supposed to be between 5 and 15. Unfortunately, you can't just define a slider going from 5 to 15 and reuse it for every rate, because all rates are always going to be equal because it's literally the same slider and not a copy of the slider. Just, yeah, keep that in mind. But this is how to make a interactive function with sliders. Pretty cool. Another option is to use some Python magic for the interactivity. And this Python magic is using function decorators, which is something really cool that I'm still not 100% clear on how they work, but I know some use cases. But they pretty much supercharge a function with extra functionality. So I'm going to copy my circle function here. And say we wanted to add the interaction power to this directly. I'm going to rename this circle 2. What we could do is use a decorator from widgets. And the way to do that is using the @ symbol, widgets, since that's the package we want, and then interact. And that's supercharging the circle 2 function with the interactivity of widgets. And of course, we need to actually give it a slider or something to work with. Instead of using the same slider as before, what I'm going to do is create a new one. So widgets, instead of a int slider, I'm gonna do a float slider. Make sure all parentheses are closed. Is that in chat? So my minimum is gonna be, I don't know, 0.1. My maximum is gonna be 11. My step, well, minimum of half, then a step of half. Description. Radius. Then it's gonna start at 1. So now we're gonna have something pretty similar to this, but all compact and neat. And now we have the same thing. One thing that, if this was being used for a user, what would I be trying to say? That a circle gets bigger as its radius gets bigger, but with how this plot is working, that's not really visible because it's rescaling everything by the radius. So that's something that you guys are actually going to have to be mindful afterwards when you do your projects, because if you're trying to show a change in scale, you can't have the scale reset automatically. So I'm just gonna add a limit to this function here. The maximum is 11, so it's gonna be from minus 11.1 to 11.1. Next, and same thing with y. And now if I want to show the user that as you increase the radius increases, they can actually see that because the thing is not auto-adjusting itself. And yeah, so this is how to make it interactive with some magic. You can do either the widgets interact and then the first is the function that you are interfacing with, or add widgets interact when you're defining the function. And of course, this can be done for more than one argument functions. For instance, we could do the same thing for an ellipsis, which I actually have here.
Juliana, could I chime in with a quick question?
Of course.
So there's no limit to that Python magic, right? Like if we wanted to vary multiple aspects of that function, we could literally just stack at widgets.interact for each slider we need, right?
I don't think it would be one on top of the other, but I think yes.
Okay.
I'm checking my notes. I don't think I used the magic for the two argument one, but we can try that right now. So 2 arguments, it's an ellipsis instead of being a circle. And I separated it in 2 functions. So the way I think the magic would come here. Then it's going to be radius 1, that. And then I think to do the other one, it's just going to be the same. So direct gets pretty big, but I'm only passing to interact 2 arguments, radius 1, which is part of the function, and radius 2, which is also part of the function. In each of them, it's a float slider with the parameters that we've set before. And I think this will work. Yes. And yeah. And so if it were 23 arguments, you could do it with magic as well, like this. And it wouldn't be a stack of interacts, but inside a single at interact, there would be a stack of the arguments.
Okay, that's helpful. Thank you.
Yep. Yep. So
I also had a question.
of course.
Yeah, I'm a little confused by how these like Python decorators work. So you're able to, so you basically put it in front of a function that you declare, and then that function will be the first argument inside of the interact in this case?
Yes.
Okay.
And I think
see.
that's in general how the decorators work. I'm looking for a link here because I have a link to how, yes, decorators work. I use them more when I'm doing object-oriented programming because you can, well, say you have a human class and a human has a height. Well, I'm gonna blame the spelling on my slight dyslexia and the vaccines. So person has a height, which is something, and of course the person can't have a negative height. That would be inappropriate. So what I could do is define a function height. See, each time it's spelled different. To define the height, and in here I could make sure that if the height is set to be a negative number, then set it to 0 and maybe throw a warning message or something. But this is a function, so I would have to call this as human dot height open and close parentheses, which is different from a property, which it would be just without the parentheses. So the way to do this with decorators is to declare this as being a property. Then this just return a hidden variable, and then you declare a setter for height. So value is value if value. Okay. So human height equals 99. If we do human height, get 99 back. But if I do -9, y. This should have worked. But that's some uses
So
for
it's not,
decorating.
you wouldn't use a getter, it's property in the case of a getter.
You can set a, well, in this case, I didn't need to set a getter, but you can set a height getter as well, and that returns something else.
Okay.
But anyway.
Mhm.
I'll try not to have to spell anymore, but anyway. Okay, so this is how to interact with a function with several parameters and whatnot. And one thing that we can already notice is that things start to be slow, right? I drag the slider and we can see that it's going because it actually is, I think, it's trying to draw each time this value changes by 0.5. And we can see on this ball here that Python is thinking really hard when I move that. And that may or may not be an issue for you, depends on the rest of your process and whatever else. But if it is, you can actually set things to be to only update when at the end or when the user tells you to update. So I'm gonna use the draw ellipses again, and just to make sure I'm not gonna break myself, I'll comment out the interactivity there. And I'm gonna do it without the magic. So widgets interact same as we had there, but now with draw ellipses as the first, and I can copy the rest here. And the only thing I need to change is that inside each slider, I need to add continuous update equals false. And now if I run this, still have the plot, but when I drag, nothing happens up until I release. So before dragging was the activating step, now releasing is the activating step. So pretty straightforward as well. We only had to add this to the sliders. And I could very well have one be continuous update and the other not. Why would I do that? I don't know, but it's an option that you have. So yeah, pretty straightforward. And please do stop me at any point.
I mean, continuous update versus non-continuous update usually depends more than anything on how long it takes to redo the calculation.
Yep.
If the plot is very fast, then doing it continuously is fine. If it isn't, it'll lag. And so it'll try to plot 500 times while you're moving the slider, and then you'll have a delay in achieving what you want.
Yep. And this was already a little bit slow for two variables and drawing an ellipses, which shouldn't be taxing at all.
Well,
So,
there's an interaction with the step size for the slider, right? Because if you're, that's probably why, like, if you had your step size not be 0.5, instead they were like 2, you could probably move at the same distance with less lag. It would just look like less smooth of a change.
yeah, and yes, and there would be, because there would be less calls as well to the function, right? But what I'm guessing is that this problem with lag and slowness, it's going to be worse in your projects than it is here for drawing an ellipses. Right, you're dealing with more complicated stuff. And there is another option to do, oh yeah, there is another option to do this not continuous interaction without doing the continuous update. So just copy everything here, remove that. And that is to just switch from widgets interact to widgets interact underscored manual. And now we have a button there for run interact. Which, depending on what you're doing, you might have to resort to this, because if you have, I don't know, 20 ODEs or fluxes going on, and you change something, it's going to change everything. But the user actually wanted to change 2 things together to see something else. Then they have to wait for the lag, move the other thing, and then finally see whatever is going on. So this might, so yeah, 3 options: continuous, on release, or on click. And that's going to depend with your personal preference to be. Yep, so that's all for an ellipsis. Of course, we should probably do this for something tellurium-like. So I've selected a pretty simple model as well, the SIR model. If I run that, we have that here. We see that susceptible cells or people get infected, go from S to I, and they either recover or they die.
You want people to do this along with you, or you're going to do an exercise at the end?
People should be going along, but I am pasting stuff that are too long in chat. So you have this box in chat.
So if you want people to do this, maybe you should let them all make sure everybody can run the base model.
Yep.
The base model works, I think, if you just copy and paste it.
And now, while we do this, yes, I could ask, how many sliders could we feasibly have for this model?
I mean, without counting, right, you're probably to set it, you're going to have one for each parameter. I mean, you can also have one for the initial conditions for each of the state variables, is at least how I would build it if I wanted to have everything flexible.
Yes. So 8. And if it was slow with 2, 8. And this is I mean, way simpler than whatever your projects are. But of course, I don't what I was gonna say. Of course, I don't expect that you have each and every parameter of your model be adjustable by the user, because probably there are some parameters that are not that interesting to see varied. And yes, I'm going to share the file afterwards. So actually, while I copy the solution over from my other Jupyter notebooks, I think I'm gonna give you all 6 minutes to create 4 sliders for this model and couple them with this. So you have your choices of things to change there. And one suggestion I give is to do something similar to what we did with the circle. I mean, I did put things inside of a function for a reason. I could have all of this just inside of the block, but then making the interaction would be non-trivial. Whereas putting everything inside functions, then I could just pass on the function to the relevant functions. Yes, passing the function to the function is actually what we are doing. So I suggest putting all of this inside of a function that takes as arguments whatever you're changing, and then somehow after loading the model, changing those parameters and finally running.
Hey, Juliano, can you show how you stack multiple again? I don't remember the code.
So it's interact, manual, whatever.
Mhm.
Then the function and the other named arguments are the names
Separate
of the
by,
arguments in the function, and then equals whatever slider you want. The other option is to do it like this with decorators instead of here.
right, just separate by comma.
Yes. Yeah, it's argument 1 equals a slider, comma, argument 2 equals another slider, comma.
Thank you.
If you finished it one way, try it with the other way. So if you've done it with the decorator, try it the other way. If you tried it directly, then try it with the decorator
Mhm.
as an extension. If you're already done.
Yep. And I would like to see the solution from somebody. See if you came up with something different. Maybe give people another minute and then I'm gonna ask somebody to show their work. Okay, according to my watch, it's been a minute since I said I'd wait a minute. So, who? Purva, have you got something? And I'm sorry if I mispronounced your name. Purva, are you there?
Hello.
Hi.
Hi. Yeah.
So, have you managed to do the exercise?
No, actually, I was doing it and I'm not able to get it. That's why I was taking time. That's why.
Okay, yeah,
Yeah.
maybe what issue are you having? Like, we can try to help out.
Oh, okay. Just. Yeah, is my screen visible?
Sorry?
My screen is it visible?
No, let me stop my share. Now you should hopefully be able to share, I think.
Yeah, is it visible now?
No.
But it's not sharing. I don't know what's happening.
Hmm. Well, it seems that. Oh, yeah, all participants should be able to share.
It's like it's showing that unable to share the screen.
Okay, but well, maybe we can do it verbally a little bit. Is there an error message or?
No, actually, I was completing it because first I was installing the Jupyter widgets and all. That's why I was updating, and that's why I was like a little bit slow in doing the
So
exercise.
you're not running it on NanoHub?
I'm running it on a NanoHub, sir, but thing is, I'm a little bit slow behind. I maybe just in 2 minutes I'll be able to do it.
Right. Well, strange because you shouldn't need to install anything. It's included with the Tellurium distribution in NanoHub.
No, I actually that's why I don't know it was not working before. That's why I was like doing it again.
Why don't you just screen share and we'll try to help?
Yeah, sure. Yeah, is it sharing?
Nope.
Yeah, now it's like showing in my screen. So you see this error?
No, we are not seeing your screen share.
Okay, wait. Let me just reconnect myself again.
Okay. Yep.
Yeah.
Hey. Somebody else wants to show their work.
I can. I think that I'm still trying to figure out if it's fully working, but I have something that runs. It's not pretty.
That's perfect.
Okay. Can people see my notebook?
Mm-hmm.
Okay, so I just opted to change the rates. I did not get a chance to do it both ways, so I used what Juliano was calling the magic way.
Mm-hmm.
And I just have it set to change the rates between 0 and 1 without continuous update. And I have it for steps of 0.01. So I don't, this might not be the most elegant way to do it, but I just loaded the model.
Yep.
And then I did the updates of the parameters the same way we've been doing it otherwise. So you
Yep.
can go ahead and drag those and make it so people die, I guess. And then you can see a lot of people die. And then so yeah,
Yeah.
I think it works. Yeah.
Yeah, that's pretty much it.
I can send this in the chat if people think this would be helpful for debugging any of the errors that they're getting.
Yeah. Yeah. I think that would be useful in chat. Oh, no. Okay. I did it in a pretty similar way, but what I did, let me get back my share. That's right. Yeah. So what I did was I first declared my sliders separately because I knew it would be quite a bit. And I also only did the rates and yes, the rates and the average number of daily encounters people have, which is also a rate, I guess. That's it. So yeah. So I have the string here and I have the model loaded already in M. So I was a bit sneaky. And so I have my minimum and maximum numbers be whatever is already there divided by 100 or times 100. I'm not sure why this one is set to be a minimum of 1 or that. But it's been a while since I wrote this.
Because if gamma is 0, everything is 0. You don't have any disease, any death, anything. It's 2 lines.
Yes. Yeah, but that would be true for the minimum here, but I set the maximum to be at most 1. I don't think that's right. But maybe I ran into some trouble.
No, min
about
is
that.
right, because if you set that to 0, then you can never get away from it.
Yes.
So you never want the top value to be forced to 0, because then you're stuck.
Yeah, but the top value here is going to be 100 times 0.1. So it should be from 10 to the minus
You're right.
4.
It should be max. It should be max of
Yeah.
1 only.
Yeah. Yeah. Number of encounters, you can't have less than 1 encounter. So this max makes sense to me. This other rates, I'm not sure why I did it like that. Peculiar. Anyway. Let me remove that, and we see some problems. We know why I did it that way in the past.
I can tell that some of these values, if I move here, but I did all 8, it crashes. It runs into a runtime error. So maybe it's that.
Perhaps. Okay, so I've defined all my sliders. Then what I did was I created the function with the SIRD model here, slider SRID, which takes as arguments the 4 values that I chose to change in the sliders. Then I have the string normally. Then I did the same thing as Yukon, all right? Loaded up the model and then changed the values here and then set it to simulate. Now I only need to do the interact. So I have, oh, because I want the results, I have this R equals widgets interact and then the function and the sliders. I run interact, yeah, that works. And if I put gamma to be 7, that also works. Yeah. Don't know why I had all those max and whatever before. And of course, my names for the sliders are not that good. I mean, gamma 1, mu, the only ones that have a decent name are the average daily encounters and death rates. The other ones I should change with something that is more meaningful. Another thing you have access to with the widgets is a drop-down widget. I'll do that. And this. And that I can select the options that I've gave, and that's that. So if you have several models that you want the user to compare, you can have them select one, then the other, change something, select the first again, or something else. But you have the option of drop down. And so I guess the next exercise we can do is reuse whatever you did for the rate modification. But instead of having just the SIRD model, have both the SIR and the SIRD models inside the function and add an argument for selection. So it would be the or SIRD, then selection. And then you'd have something like if selection if selection is necessary, so for this exercise, if you could complete this function, that would be wonderful. And you don't need to use the rates that I've chose. You can do initial conditions, whatever you want, as long as there is some interaction and the selection of two models. And to go from the, my cat is acting funny. To go from the SIRD model to the SIR model, you only need to remove death from the model and everything else should work fine. Yes. Yeah, and bonus point if you can actually throw an error, because the user will find ways to break your thing that you thought would be impossible, but yes, they will find a way.
I have a question. SRI, although you don't have def, I mean, you don't have def explicit, or you don't have def at all?
Let me check on my other screen. Yeah, I don't have that at all.
Juliano, I don't doubt on the user capabilities, but I would like to see how someone can select another thing besides the options I gave.
Yeah, I don't know how somebody would be able to, but what is the F11? No, F11 is full screen, F12. There we go. Maybe somebody really wants to, they could pull this up, then call the inspector. Will this work? And try to inject something this way. The thing is, the user will find a way. But yes, they should be receive an award. Maybe the error message should be, whoa, you really managed. I have no idea how. Here's a cookie.
I have a message.
All right. Okay. Let me check. Do a shuffle here on the name list. Okay. Danusha, have you been able to finish with the exercise? is. Oh wait, she's not on the list anymore. Okay. Guessing she left. Then Supriya, what have you got? And if it's fine if you weren't able to finish things.
Hi, Juliano. No, I was not able to finish it. I was working on the same model which you're showing right now. I was,
This one?
yeah. Not this one, the last function where we are modifying the model. Like we're selecting the model and then.
Okay, yeah. So it's fine if you haven't finished, but what are the difficulties? Because that may help me help you with doing this.
I was okay. No, I was thinking while we have this drop down, right? Which is drop down. Even if we select, how is it going to implement in the select model? The one which you are showing right now, if like there is a if condition of if selection is equal to SIRT, I'm trying to figure it out how we are going to implement the drop down and then going to the next block of code.
Right.
Hope I'm making sense.
Yeah. So let me just modify this so that it's not angry at me. Oh.
So are we, so in the block 51, so we are keeping the values in drop variable and then passing the drop into the next definition, or the next function, the SIR and or the SIRD?
Yes, that is correct.
Okay.
So yeah, this function would have access to whatever is
Drop
here.
down.
Yeah,
Okay.
in the drop down. And then you'd find a way to select one of the two models with if
And then
statements.
pass the value to the function, the SIRD function, right?
Yes, you could call this function from here. That's similar to what I did for the ellipses. If I scroll up in the ellipses here, I have one function that just gives me back X and Y for given radii. And then the other, calls that function and then just the drawing and everything. So yes, you could have this function be called from in here with the proper arguments, and that would work. Then you need to do something else for the other one. But
Thank you, Julian.
yeah. Great. Anybody wants to show their work?
Yes, I would like to.
Go ahead.
So I took a slightly different approach. In this case, I defined a parameter list that has all the different parameters, but we only have one if condition, and that will just remove the depth. Then when you pass it in, it only includes what you need. But the reason I wanted to show my example is also because I have this styling and layout that controls the width of a description. So you can fit in a longer one by passing these to your dropdown.
Cool.
But
Very
like Professor Glazier said, it gets ugly. Like you have to define the exact number of pixels. And even if you say auto, which would be like that, you might have things that get like this or staggered. But that's all.
Pretty cool. Yeah. Just one thing on that make plot function. I'm not sure that what you've done is actually what you think you've done. Because the SIR model is supposed to have a different result than the SIRD model by itself. So when
I
you
see.
change the two options, you are changing the plot, but I think the only change you're making is to display or not the number of dead people. But even on your SIR model, you still have dead people because it's the same baseline model.
Yeah. So whatever D is, I have to modify some of the parameters using M dot.
Yes. One thing that you could do is just set the KID to be 0 in the case of the SIR, and that would do it. But it's kind of hard to see anything because the numbers are so big.
I see.
But yes.
Now, wait a sec, switch it to SIR.
Yeah.
So it doesn't plot that one because the value doesn't change.
No, but we can see that the number of recovered people actually increased if you change back.
Yeah, you're right. Good.
Yep.
I guess you should, if you really want to make it clear, you'd have two totally different models, so there was no way you could confuse the two.
Yep. And I actually think your way, Pete, was more elegant than what I did because I pretty much had the full model string in each of my if blocks. And then loaded up the model. And then I had another if for the case, because since I had two different models, my SIR model didn't have the KID parameter. And so if I tried to set it, of course, Python wouldn't be happy with me. So I had to add another if for in the case of it being the SIRD and only in the case of the SIRD to actually touch that parameter. But yours was way better, Pete.
Thank you. I will post the code.
Yeah, thanks. And yeah, that more or less, let me check here.
Maybe Peter, you could also email me the code and I can distribute it that way too, so everybody has it. Because those formatting functions are, I mean, they're documented, but they're not, as you say, they're not very convenient to use. And so having an example where they work is a good place for people to start.
Yep.
Will do.
Thank you.
And that more or less covers all that I want to talk about widgets.
Did everybody get it to work? Is there anybody who has not gotten this to work?
So I have a question.
Sure.
How difficult would it be to have a drop-down menu and then have the sliders be dependent on the model that they select from the drop-down menu? Does that mess with the syntax that we've been using? Yeah, that's what I was trying to do, and I was making some mistakes as I was figuring out what was allowed and what wasn't.
Excellent question.
I have a solution for that. You can wrap up another function.
Yeah, that was the solution that I was arriving at. Have one interact drop down, select, be sent to a function that then creates the other sliders that then get called to the model.
Do you have to destroy the sliders if you do that to get rid of the ones that you created for the first model, or did they automatically go away?
I think they should go away. Let's try it.
You're not screen sharing.
Yes. Here. Okay, so Okay. I mean, I can define a function inside of a function.
Yeah, you can probably pass the widget interact manual thing on that one. And then you can pass another. Oh, yeah, okay. The function inside of the function.
Yeah. Copy the drop down. A and E. Then to make my life easier, I'm gonna reuse here on the other screen. Reuse the pieces. That's yes, we can do the circle.
I hadn't considered that you could do a function inside of a function and keep using the magic solution, which makes this a little bit nicer to look at than what I was trying to write.
Yeah, well, maybe it won't work. Let me test first, and then I'll allow you to be impressed. Widgets. Okay, run interact. Ready to be run interact. Yeah, that works. Cool.
And what if we didn't have a manual on the dropdown?
Oh, without, yes.
So then you'd have to have an option that was nothing.
Nope, it just does it.
It switches it automatically.
Yep. I'm surprised. Didn't think it would work this nicely.
So that's code that might be shareable too.
Yes. Yes. And this kind of thing is why I really like Python and why some people really dislike Python, because as you can see, it's pretty easy to do some pretty hacky stuff that is not good practice. But whatever.
Okay, any questions about this? That was a lot of material. The online documentation for the widgets isn't bad.
Yep.
You want to point people to the manual for that, the online manual.
Yes. Let me find the link again.
The one thing you have to watch out for is that not all of the widgets that are in the manual are supported by Tellurium on NanoHub.
Yeah, so the manual that I've pasted, as you can see in the URL, it has 7.x, so it should be more compatible to the NanoHub version. And in creating this lecture, I've also used those guides or those blog posts, whatever, as guides.
But I think there are a couple that aren't there. That, for example, I think 7.x has free text entry. I don't think that works in NanoHub.
Yeah, I don't think there's a free text.
So don't get too attached to a specific widget until you see if it's there. in the
Yep.
NanoHub deployment.
And yeah, just I think it's better if you do your slider development on NanoHub just to be extra safe.
And I tried a different solution than yours, Juliano, and didn't work. It works for some, but not for all. I don't know why. You want me to share my screen too?
Please.
Like I did something even uglier. And I just said something like, there is a meta choice, and if I say it's true, then it runs this widget. If it's not true, it runs this widget. Of course, the first one works. And then if I do true, oh, opposite, true, then I do have a different here, but only for the drop down. For some reason, it's still grabbing the widgets from the other one.
Well, but on your false option, your dropdown is only SIR.
Yes, exactly. That's what the change I wanted to do, to see if I can have a different, if I can run a different one. You know what I'm saying? But I think because I have in the model, yes, wait, on the declaration of the model, no, the function ends here. And yeah, I thought this would be a solution, but it's not. I'm passing different widgets than here. But for some reason, it's still drawing. Of course, now it crashes everything. Anyway, it didn't work.
I want to cover a few very simple things in Antimony, much less complicated than what we did before. And there are some of these may be things that you've already done. And if you have that SIR model running, you could use it instead of the one that I've got here on the screen. So I'd like everybody to fire up Tellurium and do this. What I'm going to be talking about is something which we've talked about before, which is that we know that the equal signs are only evaluated on a load in Antimony. And so if you change, that's fine if you're changing a parameter or you're changing the value of a variable from outside of Antimony. So let's suppose that we start out with something that looks like this. A goes to B at a rate K1 times A. B goes to nothing at a rate K2 times B. We start out with 10 units of A, no B. Set our parameters here. I've got 0.2 and 1. They could be 1 and 1. We run that and we see concentration versus time like this. Now, if I wanted to make K1 time dependent, or if I wanted to have K1 be a function, say, of K2, suppose that I had something here that looked like the following. Suppose that I said K1 equals 0.2, K2 equals 3 times or 5 times K1. If I say K2 equals 5 times K1, then K2 would be 1. However, if I change the value of K1 outside of Antimony, if I said m dot K1 equals 1, that will change K1, but it will not change K2. Because the equal sign is only evaluated when you load the model. And so if I want the update of K1 to change K2, then I would have to make K2 functionally dependent on K1. And Antimony has different kinds of equal signs for these purposes. Just the way in Python you have single equal sign for assignment and double equal sign for logical comparison or comparison of equality. And Antimony has a single equal sign, which is evaluated only on load, and a colon equal sign that defines a functional relationship. And so in this case, we're going to make K1 a function of time. That has to be a functional relationship. And we do that with the syntax colon equals, and then the thing that we want. So why don't people try this and see what you get? So this is their exercise. And I'm going to go around the room and call on people to show their results who are not always. There's some people who talk all the time, which is fine, but we need everybody to talk. So I'm going to start at the bottom of the screen. And so Purva, I'm going to call on you first, and then Danusha, and then Supriya probably. Supriya, you already talked once, so maybe the next person would be Lindsay or Grant. But I want to make sure that everybody has a chance to present their results. So is this little exercise clear? Any questions about that? And of course, you don't need to have the comments. You could make it a simpler model. And if you're really typing this to save yourself typing, you don't have to name the reactions either. If you've completed the basic exercise and you want to explore a little bit more, you could, instead of using the sign of time, you could use sign of A and see what happens. Okay, Purva, would you please show us your results?
Actually, I was just doing it, but I'll still share my screen this time.
You could do it. We could do it together. That's fine.
Yeah. Is it showing this time? Yeah.
That looks fine.
Yeah. Yeah. Um, I was actually just doing it right now. So.
Okay. I don't know, Danusha, do you want to show us? Are you there?
Yeah, I'm doing it as well. Pretty much like the same stage as hers.
Okay, well, maybe just screen share it. We could walk you through it together.
No, can't get.
So this is where I am.
You don't need to have the comments. They're not necessary. Save yourself some typing. Comments are nice, but when you're typing for an exercise, you don't need.
Okay, there it is. Where is my code?
Okay, so you need to load that and run it.
Okay.
You lost your screen share.
Code.
Okay, so you need to load that and run it.
Okay.
K1 be a function, say, of K2. Suppose that I had something here that looked like the following. Suppose that I said K1 equals 0.2, K2 equals 3 times or 5. Sorry, Danusha, do you want to screen share again and show us what you've got? Okay. Does anybody want to try to help out here in this example? Does somebody see what they could do to maybe help Danusha implement this function?
So we can do it actually in the model string, right? So for the, instead of saying your K1 equals 0.2 as a constant, you can say K1 equals 0.2 and then put plus. And then instead of, you're not using numpy sign, you're just using sign within the antimony model, I'm pretty sure. So if you go to that, either of your constants, I guess, it's fine. But I think, yeah, so now move the cursor over so you're at the end of that number. But before the semicolon, yep. And then say plus. No, keep the, well, I guess you could do it either way. So say plus, and then sign, S-I-N, not numpy sign, just, yep. And then in parentheses, write time. And I think that might.
The colon.
Oh, yes, that's right. That's right. I'm sorry. The screen, it's really small for me, split screen.
Try it without the colon first and see what happens. That's actually a good demonstration of the issue. So run it without the colon. Okay. And now put the colon equals. What will happen? What will change?
Lindsay just made a good point in the chat for why this isn't working.
Yeah, you're loading in the wrong string.
So see where you're saying Taylota, you're loading the SIR string, but you have the model that you have declared as just ant string. Yeah. Not the so you need to write ant capital STR there, I think is what you're. Okay. There we go. So that's the demonstration I think that Professor Glazier was just talking about for when you don't use the semicolon equals. Yeah, colon, not semicolon. Goodness, sorry. So go over to your K1 and see where how you're saying K1 equals, make it colon equals.
So what's happening when it's a regular equal sign rather than a colon equals?
It's only initialization, right?
Right.
Yeah.
So what's the time when the thing starts?
It's
Very
0
good.
and then sign of 0 is 0.
Yeah. I have actually something I haven't tried, which you could do is in the simulate function, start at time 10 rather than 0. See what happens. It's a little hard to tell is that different or not. I don't know whether whether it pulls the time as 0 or whether it starts whether when it parses it, it reads it. And no, it won't. It'll always read the time as 0 because on the load, it doesn't know what time you're going to start the simulator.
Mine look a little bit different. Yeah, there we go. It's the same as her.
Yeah. There we go. So this is a good illustration of the issue. Thank you. That's great. Okay. Did everybody get something that looked like that? What happened to my screen share? I'm sorry, Zoom didn't update today. And the interface has changed slightly. So, okay, are we back to my slide? Thank you. Okay, thank you, Danusha, for being patient about that. So this is what you'll see here. And again, now K1 will always be a sign of time. Perhaps this one isn't so exciting, so it's not worth doing this since we don't have a lot of time. We can have any functional form we like. The other one that is the one that we run into pretty often, and it has some annoyances to it. which we will encounter. So suppose that I want to have something scale. Suppose that I say I want to change the value of A, and I want B to be 3 times A, and C to be 10 times A, and D to be 15 times A. Well, then when I change the value of A, I would like all of them to change. So let's try that. Let's say here, K1 is equal to, our colon equals 0.2 plus 0.1 times time, or the sine of time, if you like. And now you say K2 equals 3 times K1. And I think actually here the code snippet that I have in the text don't agree with each other. So there may be a collision. But let's just start out with a simple one, which would be, let's write, the code snippet is not what I want. I apologize for that. Let's start out with K1 is equal to 1. And say K2 equals 3 times K1. So let me annotate that, fix that. So make this line K1 equals 1.0. And then we'll say K2 equals 3 times K1 and run that. So ignore this one for the moment and ignore this one and see what you get. Okay, everybody do that. Now, one way to do this, which would be, I probably should have had Antimony running myself. It would have been easier to show it than writing, but since this is how we're set up, we'll go with it. One thing you could do here outside is you could now load and run the model and now change the value of, so let's say I loaded the model and now say m dot K1 equals, we had it be 1, let's make it 2.0 in the Python. And now let's print m dot K2. You'd like K2 to change, but it won't. So I want everybody to try that and see whether what happens, okay? Is it clear what I'm asking you to do? I realize it's not very pretty to do it right on the screen. So what did you get? Did it update or not? I see Zachary shaking his head. Now change K2 to be colon equals 3 times K1 and do it again and see what happens. Does it update or not? Now it updates. So you think everything is wonderful. Now try m dot K2 equals 3. What happened in the Python?
I get an error.
You get an error. You can't overwrite a value that's functionally defined. Now, if you have a whole chain of things that are all dependent, you say A equals 1.0, B colon equals 2 times A, C colon equals 3 times A, and so on, that's fine, provided you always want to change them together. But you could imagine in your simulation that you just want to change C, then you can't do it. And so you have to come up with some workarounds for doing that. One way to do a workaround would be, instead of having this be 3, would be have that be a parameter, K4 times A, and then you'd change K4 to get this to change the value. So it's this functional identity is nice in some ways, but it does limit what you can do from Python. So that's something to be aware of. Okay. So this was just working through that example that we've defined. Another thing that we can do, which is worth noting, is that I've encouraged you always to use arrow diagrams, to use reaction diagrams to define your relationships. And if we really wanted to, we can always write an ODE, implement an ODE by writing nothing goes to A, semicolon, K1 times B here. And that would be equivalent to writing dA by dt is equal to K1 times B. That works. And there's nothing to prevent us from doing that. We can always do that. There's an alternative syntax which looks more like the math, which is to use the prime here. And prime defines d by dt. And so if I write K2 prime equals 3 times K1, that will work. And so why don't people try that out? Here, one of the things that might be a little bit surprising is that, well, maybe not. K2 is now a variable, so it needs an initial value. So try this code. K2 equals 1, K1 colon equals 0.1. This is actually, I would do sine of time instead of this, it's prettier. And then K2 prime equals 3 times K1. Try that, see what it does. And maybe Purva, this time, why don't you show us what you got?
Professor, you asked to make K1 as 0.2 plus sine of time.
Mm-hmm.
Okay.
I mean, if you'd rather use 0.1 times time, anything that's a function of time, it's a little easier to see that it's working when you have something that oscillates rather than something that has a continuously just increase.
Okay.
I'm not coming up with anything that's biologically meaningful. I just want you to be able to see immediately whether it's doing what you want. So if you want to show us what you've got, that would be.
Just a second. I'm actually completing the code. So.
So a workaround would be, instead of having
Actually, I'm getting an error.
Why don't you screen share it so people can help?
Yeah. Yes. I'm getting an error here.
The tellurium load function has a typo. It needs to be ANT instead of just AN. It also looks like you're using a capital K when you do K2 prime. So you have 3 times capital K1, and I think it's going to probably want that to be lowercase because you've defined it lowercase above.
Okay, and so actually I'm getting this error every time whenever I'm doing it, that te.load a, and whenever I'm putting in my program, whatever in my variable, so it's not showing me what it needs to.
Why don't you show us the error message? Scroll down, show us the error message. Okay, so this is a typo. Let's see what you've got.
I think you might also need a starting value for K2, not just K2 prime.
Yes.
Oh. Okay. What should I add here?
Mine's working fine with K2 equals 1.
Yeah, you have to add K2 is equal to 1.0 and then remove a semicolon that you've added extra in the pointer variable cursor, right? And add a K2 below to A and B variable.
So A.
No, yeah. Before K1, you need to add define your variable K2. K2 is equal to 1.0 and a semicolon. I'll just this report. No.
So why don't you
Sorry, you are loading your model into N, but then you are passing M to the relation. So you need to keep as in the N there, and in the plot also you have to replace it with N.
There's a syntax error in the code in the Antimony. Let's see if we could figure out what the syntax error is. Unexpected open parenthesis, expecting text string. So why don't you get rid of the model 1 constant decay? We don't need to name the model.
I think the issue is the one with model.
You have a semicolon that needs to be added after B, the J1 reaction.
There you go. And then get rid of the and at the end of the variable.
I'm sorry, can you repeat
Get
that?
rid of the n.
N.
Get rid of that.
Okay.
Try to add one more semicolon after the J1 reaction in the J1 reaction. B tends to 0, and then you have to add a semicolon. Second line, third line of the
yeah.
Line. Yeah, there you have to add a semicolon.
Okay.
Before to K2.
Yeah.
There you go. Good. You'll notice K2 is now a variable, so it's being plotted.
I think we wanted K1 to be colon equals.
Yeah. It has to be continuous. And the K1 variables are there is something, so you need to add a column over there. K1
K1.
before equal to, yeah, before equal to you need to column. Not
Yeah.
before equal. Not basic. Check in the chat, Sean.
Okay.
You can look at the syntax in the example that you have up on the YouTube screen. There you go. There you go.
And even for the two, should I do that too?
What will happen is, well, we could try it, see what happens.
Yeah.
Now, what have you done? What's the difference between the two?
Before this, you were
That's
getting,
not where you started, though.
yeah, it was this.
What does K2 prime equals something mean?
Okay. Where is it?
So I think you hit the right button, but there's a space there. So you need to have it up against the I can't, it's really small on my screen because I'm split screening my code, but I think if you back up one space, it looks like you pretty much have it. But in general, I think if it's filling in two, it's because you have them apart. I think that if you have them right up against each other, we'll only put one.
Yeah.
So K2 prime equals something means that the time derivative of K2 is the thing on the right. K2 colon equals means K2 is the thing on the right. So in one case, you're defining the time derivative. The other case, you're defining the value. They're both legitimate things to do depending on what you want to do. Okay, great. Thank you very much. That was great.
Sorry, could
Okay.
I just ask a quick question
Sure.
about
Gabriel, go ahead.
So is there a reason why we usually would have been doing, is it just for like going over everything? Is there a reason why we haven't been doing the time derivative version as opposed to like, because I'm trying to think of how to do things like, because isn't in Antimony, can't you do like a dash and a dot to do inhibition or something like, or a dash and a circle, like the lollipop thing to represent inhibition instead of the arrow? I thought I remember reading that in one of the reference notation things, but I was trying to think about how to do that with using time derivatives instead.
Well, so we'll come to that in a second, actually. That's actually more or less my next slide or two. I mean, the main reason that an arrow is useful is that if I have A goes to B, this says dA by dt equals minus K1A, and dB by dt equals K1A. So this one line gives me both of these together. And if I had stoichiometry like 3 and 7, it would automatically handle how many of A I have to take out, namely 3, and how many B I create, namely 7. So it would handle all of that automatically. If I wrote these independently, then I would have to keep track. And so if I wanted to change this function here, I would have to change it here and here. So if I wanted to change the rate law, I would have to change it in 2 places. And so the answer is that they're both, you can do the same thing with both. But when you actually have chemical reactions or a chain of reactions, the bookkeeping is handled much more simply when you use the arrows than when you write the ODEs. The other thing about it is that if I give you a stack of ODEs, so if I give you a bunch of chemical reactions and ask you what the ODEs are, you can unambiguously write them down. If I give you the ODEs and ask you what chemical reactions led to those ODEs, in general, you can't tell me. There are many different chemical reactions that lead to the same set of ODEs. And so you can't invert that. And as I've mentioned, in some years, I've actually given people a famous article, the Tyson cell cycle oscillator article, where he writes everything in terms of ODEs. It's a very beautiful paper scientifically, but he gives you a stack of ODEs. And I'll say, what are the chemical reactions that he's implementing? You can't tell. And so the answer is, it's not that one is right or wrong, but some of them may be easier to interpret or easier to remember what you did after the fact, or it may be easier to change things. Joel, did you have a comment?
Isn't there like a tellurium function that I can get the ODEs from the equations, from the... Do you remember what it is? There was a day that I was trying to get that automatically, but I couldn't. Like, I thought it was get ODEs, but I don't know. Just get ODEs without anything, didn't return what I was expecting, returned the whole model again.
I have to say, I've never used it, so I'd have to look it up in the manual. I don't remember that.
Because it might help us when calculating null points and stuff, because you can get the whole form for the function. Anyway.
I mean, I don't know this function. I think Gabe knows it because he just posted in the chat, but the one difficult, I don't know if you could just pass that into the Python code that we were using to find the points, because the syntax for equations in Antimony is slightly different from Python, right? Like, I think powers are different and whatnot. So I think you would still, I mean, I guess you could do a string operator that looks for what's mismatched, then you could automate it that way. But that's just something to be mindful of if you try to do that.
I mean, I think another thing that you can do, and maybe somebody can check this while we're here. And I didn't know this until I saw one of Herbert's code for doing the phase portraits, which is, I think, that the time derivatives may be defined. So J0 gives you this rate here. So if I do simulate 0, 10, 100 time J0, then that will return the value of J0 versus time. That's one reason to name it. I think that A prime may be defined. So if somebody wants to try doing simulate 0, 10, 100 time, and then quote A prime, close quote, and see whether that works.
Yeah, it is, because we use that for the field, vector field, right?
Does somebody want to try it here and just see if it works? Because Antimony does create those ODEs when it's parsed. And so I think that that's a default symbol. A prime is a default symbol. So that, Gabriel, that was a very good question. Maybe a longer answer than you wanted. Does it work or not work?
I know Zach and I have been using it, so yeah, but he's right. It's actually it's a Tellurium method, not a R.
But I think the symbol variable prime is predefined, isn't it?
Yeah, it does work. I can do anything.
Maybe
yeah, you
make
just
a
have
note.
to include the model in the as the parameter for the function. So in this case, it would be, I think, M or whatever you have as the te.load A.
Oh wait, James, I think I did something wrong. It's almost impossible, I think, to write a prime when you're passing as a line.
Yeah, does it
Because
just think you're putting the
it thinks you're gonna write a different, it thinks you're gonna write a different thing. Here, you see, like if you pass prime as like that, let me try to with doubles. Maybe doubles will solve this. God.
There you go.
Yeah, doubles it works. Okay. So it's the time that you use doubles instead of single quotes. So if
Yeah,
you
so
want the
that's
prime.
yes, you can't use prime as the quote symbol for prime. Because that'll give you a mismatched quotes.
Yeah.
It's an unfortunate choice of special character, isn't it?
It is.
Does everybody follow what we're doing? The A prime returns the time derivative of A, of the variable A. So that's a predefined function. Great.
You can't use the escape character, just backslash before it. Does that not work?
Might be. Might work. Let's see. Single, and it's back. Single. Is that how it is? Yes. Yes, you got it.
Okay, so that works. I would probably just use the double quotes.
It looks cleaner. Yeah, but I don't know. I was even trying this as we were talking, because I thought it would be something, but it. Am I doing something wrong here, Gabe? That you've been using this before? Do I load the model? Do I use R here instead? And
It
then
wouldn't
it
have an argument.
expects nothing. Yeah, like that, because I'm loading it here.
The way we've been using it is you use, so it's actually te instead of R or te, and then you put your model in as an argument.
Model test. Yeah, or should I just write the whole
No,
thing?
you have to put R in, not model test.
R.
Yeah.
That should
Oh
work.
yeah.
Awesome. All right, cool.
Now you need to print the result. So you need to assign it to something and print the result. There you go.
Yeah, great. Okay. Nice.
No, the conversion features are quite powerful in Antimony. I mean, it's not mathematical quality, a symbolic manipulation, but still, for a simple program, it actually does more than you might expect. Okay. And I learned something because I'd never used that function. So maybe Giuliano, you could make up a slide that captures some of that for us. Because I think there are a lot of good insights here that we should probably add to the deck. Great. Okay, any other discoveries that people want to share? It's nice that people have been digging and discovering new things you can do with Antimony. That's great. Okay,
I have a question.
sure.
Yeah, so once we load the ODs using this get ODs from model, can we modify those ODs? Like, is it doable, or like, have anyone tried working on it?
So that's a good question. So maybe we come back. Joel, you want to screen share again? So let's instead of printing it, make a value, assign it to a string. So set a string equal to t get load. Instead of printing it, just set string equals that. Okay. So now the question would be, can you load that? Can you use t load a on that string? Does it work?
I mean, that doesn't include the
Yeah.
parameter values or anything, right? So
I don't think it'll work
yeah.
unless they're there hidden. But I don't think so. I think they're.
Yeah, there is, because of the format that is written here.
So the
This is
question.
not. Sorry.
So the question was a good one, but the answer is it's a one-way conversion. You can't undo it.
Okay.
Excellent question. I didn't know the answer.
Thank you.
Other comments or questions? These are good. It's great to be exploring together. Okay, so after that, we only have 10 minutes, 20 minutes left. I want to finally get us to the feed for. I guess it's good that I didn't pre-assign the homework already. I keep delaying this homework assignment. I hope people are working on their projects. I know people. I talk to some people who are. I want to come back to this feed forward network. And this is chapter 14 in Herbert's textbook. And in some ways, this is not the most exciting network in the world. Spending a lot of time on it seems a little bit less exciting than the ones we did 2 weeks ago, which were networks that were more functional. But this kind of feed-forward network you do run into quite a bit. And it does address the sort of kind of qualitative and semi-quantitative and quantitative questions that we were talking about a few weeks ago, which is, suppose that I have a molecular species P1, and it affects molecular species P3, and it does it in two ways. It does it directly. P1 does something to P3, and it does it indirectly via P2. It does something to P2, which does something to P3. And I've used arrows, pointed end arrows, which I shouldn't have done. So you can ding me for that. But let's just think about all the possible combinations of regulation that we could have. I could have P1 promote P3, activate P3, P1 activate P2, and P2 activate P3. In that case, if I have more P1, I get more P3 directly. I get more P2, and more P2 means more P3. So both of these circuits are pushing in the same way. That's called a coherent feed-forward network because both paths are trying to do the same thing. Increasing P1 means I get more P3, both directly and indirectly. The second one maybe is a little bit less obvious. Here I have an inhibitory arrow, inhibitory regulatory arrow. So the more P1 I get, the less P3 I get directly. Increasing P1 decreases P3. Why is it coherent? Here, increasing P1 decreases P2, increasing P2 increases P3. So if I increase P1, I get decrease P2, which means I increase P3 less, which means I decrease P3. So a direct arrow, which is inhibition, and a pair of stacked regulation, which is inhibition followed by activation, are both inhibitory. So both pathways mean that as I increase P1, I decrease P3. Does that make sense? What about I reverse the order? Here, increasing P1 increases P2. The more P2 I have, the less P3 I have. So increasing P1 directly decreases P3, indirectly increases P2, which decreases P3, so it decreases P3. So I'm pushing in the same direction again. The third one, P1 increases P3 directly. P1 decreases P2. Decreasing P2 increases P3. So increasing P1 increases P3. So two minus signs, two negatives make a positive. So I have all of these are all the possible combinatorics I can have. These top ones, I'm pushing in the same direction in both. The bottom row are what are called incoherent feed-forward networks, because the two paths are pushing in different directions. Here, P1 is trying to increase P3 directly, but through the indirect pathway, it's trying to decrease P3. And so until I know exactly what the mathematical form is in the parameters, I don't know which of them is going to win. And so in this case, I know just from the architecture, increase P1, I get more P3. Increase P1, I get less P3. Increase P1, I get less P3. Increase P1, I get more P3. I don't have to know the parameter values, the functional forms, or anything. Just the arrows tell me. In the ones down here, I need to know the details to know which one will win and how. And so these are three incoherent networks beyond the one that we started. And so there are 8 possibilities. You might ask the question, why would you create a circuit where the two things are fighting each other? What good is it? And the purpose of the exercises in chapter 14 and the yet unassigned homework problem is to explore a little bit about why you might want to do that. And typically it has to do with ranges of behavior and in time. So we might ask for a circuit of this kind. Do the species concentrations increase or decrease in time? How do the equilibrium output levels vary when I change parameter values? How does the rate of stabilization, because these eventually all lead to stable steady states, change with parameters? If I have something that's transient on my input, how does the output change? If I have an input pulse that goes up, does the output respond rapidly, slowly, same shape, different shape? If I had something like a sinusoidal input, what does the output look like? And if there's noise in the system, what happens to it? Is noise amplified? Is it filtered? What does it do? So the way we're going to analyze this problem, we're not going to get through it all today, is going to be the following. What we'll first look at is this feed-forward network is composed of 3 essentially identical single-step networks, P1 to P3, P1 to P2, P2 to P3. All of them are either a green activating arrow or a red inhibitory arrow. And so the first thing that we'll do is just say P1 does something, or A does something to B, which is easy. We've been doing that a lot. And how does that depend on its parameters? So the first question is, what happens if we change the value of P1? What happens to the value of P2 in time? The second one is what happens when we look at the double step. If we think about this, the time derivative of P3 depends on P2. Time derivative of P2 depends on P1. So this is a second order differential equation. The relationship between P1 and P3 is a second order differential equation in time. The direct is a first. And so we can think of this as two ODEs, one of which is first order in time and one of which is second order in time. That gives us the possibility to have a little bit more complex temporal behavior. And then once we've done P1 to P2 to P3 direct, P1 to P3 direct, we combine. I will remind you, and this comes back to where we were talking before, notationally, that P1 activates P2 if these are genes, is interpreted as P1 is a transcription factor that turns on gene 1 that produces P2. And as a reaction, that is nothing goes to P2 because P1 is not used up at a rate that depends on P1. And that regulatory arrow that we have here is useful for keeping track of things, but in our chemical reaction notation, it doesn't exist. It's just a decorator. And so all this is nothing goes to P2 at a rate V1 of P2. We might, if we want to be finicky about the actual fundamental dogma of biology, remember that the production of protein isn't happening directly. It's happening through messenger RNA. We also might want to remember that here we say P1 activates P2. And in principle, that would mean by itself that you get an infinite amount of P2. And we never get an infinite amount of protein. And so there's always an implication when you see P1 lollipop P2 that P2 decays. And so you're always going to interpret this as first order decay. And so actually this P1 goes to P2 actually turns into nothing goes to P2 at a rate depending on P1. P2 goes to nothing at a rate depending on P2. And so there's a certain amount of interpretation that you have to do when you see a diagram like this to turn it into something that's computable. Joel.
Could it be that P1 is also first order decay in this? So you don't have the signal turning on all the time?
So you could certainly have P1 have some functional form, but this diagram doesn't tell you anything about P1. It doesn't say anything about how P1 is created or destroyed. Presumably, if P1 exists, there's something upstream of it. But as far as we know, P1 is an input, would be in antimony $sign P1. It would be about what we call a boundary species. Good question. Okay. Once we've done that, we have to have some hypothesis about the functional forms for regulation. And we will discover that in our world, when we don't know anything, we use Hill function. The standard way to encompass our ignorance is a Hill function. Why is that? Normally, if we have an activator, what we know is that As we increase the amount of P1, the rate of production of P2 goes up. So we need something that's monotonically increasing in P1. For signaling networks, typically you assume that if there's no P1, you don't get any P2. For gene regulatory networks, there's always a small basal rate of production of the product. So this B1 is there. Even if there's no input signal, you get some of the stuff out. And then we use a sigmoidal function. Why is there a sigmoidal function? Because there's a maximum rate of gene transcription. And so no matter how much activator we have, there's a maximal rate at which we can produce protein. So we know there's saturation. And that's a biological observation, not a mathematical observation. And so we're going to use a Hill function. VM1 is the maximal rate of production. K determines the threshold of value of P1 at which we go from producing only a little bit of P2 to producing a lot. And N, the Hill exponent, tells us, is that transition gradual or sharp? The nice thing about a Hill function is that we really only, well, we have a relatively limited number. In principle, there could be any number of relationships, arbitrary relationships, with an arbitrary number of parameters. Here we have a parameter B1, basal rate, parameter K1, the value of P1 at which we're producing half our maximal rate of P2, VM1, the maximal rate of production, and that's it. And N is the steepness of the slope. And N usually doesn't have a huge effect. So we really have reduced our ignorance, our total ignorance, to 1, 2, 3 parameters. It would be nice if we could reduce our ignorance to fewer parameters, but reducing the potentially infinite amount of ignorance to 3 parameters is pretty good. It's managed. Our decay, we're always going to assume first order decay. Just a constant times the amount of stuff we got. And so we now have gone from P1 goes to P2 to actual equations for our network. And we will discover that while it doesn't work 100% of the time, this mapping works most of the time. You may have to do some pretty creative thinking to determine what B1, K1, and VM1 should be. But even then, you're going to discover that there's some rules. In particular, if P1 is always a lot less than K1, the circuit never turns on. If P1 is always a lot bigger than K1, the circuit's always turned on at its maximal rate. And so you know that K1 has to be comparable in value to the midpoint of the range of P1. So if you arbitrarily define P1 to be between 0 and 1, then you know K1 is going to be about a half. So you actually then have eliminated K1 from your consideration. You've got one fewer parameter. There's a time scale. VM1 is a time scale. You can always get rid of one time scale in your problem. Usually you get rid of the one in the decay constant. B1 you still have to deal with. So really the number of free parameters in this model is fewer than you'd think. Okay, that was pretty fast and we'll go over it again, but I want to make sure that this argument is something that, again, I don't see people teach it very much in the textbook. And it's so fundamental to the way you build models that I think it's pretty important to discuss. When you start with a very abstract model like this, you say, what do I do with it? And there is, in fact, a standard sequence of things that you do to interpret it. All right. This slide is maybe a little bit overcomplicated, especially at the end of a class. But this is talking about scaling. And I made the comment that, and you don't have to do this, that we can always change the time scale of the problem to reduce the number of parameters by 1. And so here what I've done, and it's something that you'll see, actually, I think Peter, this morning, I was talking about his project with him. He was showing some simulations that had been written in a paper that he was reading. And we were looking at those together. And they had done exactly what they had gone through in the paper, exactly the steps that I'm outlining here. And one of the things that you see often is that the rate constants are not a single rate constant, but a product of 2 rates. And you'd say, why would you do that? And the answer is that if I rewrite Vm1 equal to K1 times the decay constant, and B1 equal to C1 times the decay constant, let's see what I get. C1, KD1, KD2, K1, KD2, KD2, P1. Notice that I can now define the steady state by setting the time derivative to 0. And now all of those KD2s cancel out, right? They all disappear. Boom, boom, boom. And so I discovered that my steady state, P2 star, is C1 plus K1, P1 to the n over K1 to the n plus P1 to the n. Notice I have 1, 2, 3 parameters here. I had 1, 2, 3, 4 parameters before. So there's actually 1 fewer parameter than I thought. That means that if I change KD2 in this equation here, I don't change the steady state. And this is a plot of that. Here I've set K1 equal to 1/2. And so this is the basic functional form that I'll see again and again. C1 is that baseline rate of production. These are the steady state now, not the rate. C1 plus K1 is the maximum value of steady state. The midpoint is at K1. And so now I have a full steady state analysis of this problem. So I've gone from doing the rate equations to getting the steady state analysis. All right. So that's where we'll stop. I went through that pretty fast. Next time we'll come back and do it again, slower. And I may give you assignment. I don't want you to have, I don't want to walk you through ask you to do all of the analysis of this problem, which takes a while, without doing it in class. But I may, depending on, I'll think about it, I may ask you to do this simple analysis of the steady states that we've done here for one of those networks. Okay, any questions before we break? I know I owe people some one-on-one meetings, so I would be happy to try to set those up the remainder of the week. Questions or comments before we stop? Okay, people are tired. Thanks to everybody who showed their screens, even if things weren't always working well. I think, again, the class is a good resource to help each other. And so it's important to do that together. Okay, last opportunity for comments and questions. Okay, I will try. If you want to meet with me one-on-one, please send me a reminder, because it's possible the email you sent last week got lost, because there were a lot of emails last week. As I always say, if you don't get a response, call me, because it's not that I'm trying to ignore you, it's the email got lost in the stack. And I will try to meet with everybody who wants to meet about projects this week and help people along with that. Okay, and thank you again, Juliano, for doing the demo on the widgets. And thank you, the class members, for coming up with really neat solutions to problems. It's always great to see that creativity, and I hope we can capture some of that and integrate it for next year so that students have that material available to them. Okay, thanks everybody. Good night.